It's fun time.
Look at that. This'll do. It's really cold up here though. Alright, welcome back to the Firefly Esk8 build. It's way colder up here than I anticipated it to be, so I'll make this quick. In the last part, we went over all of the preparation work to make your Firefly build. And so, this guide has been a long time coming. Without further ado, let's get started on how to build your very own Firefly Esk8 remote. So you've been waiting weeks for all of your parts to come in from all of your various sources, but now they're here. First up, we're going to want to take inventory of what we have to make sure everything that you need has arrived. For me, I've been putting everything into the box that came with my Hobby King order. So let's lay everything out on the table and start checking things off the list. We've got the Arduino Nano V3 boards themselves, the LiPo charging circuits, the LiPo batteries, the 5-volt boost converters, OLED screens, Hall effect sensors, micro switches, springs, screws, as well as the wires, NRF remote boards, USB ports, magnets, and last but certainly not least, are my resistors, capacitors, and slide switches. Alright, cool. Looks like I've got all of the electrical components, so now let's check on my 3D printed housing. Keep in mind, I printed one of every part, so you'll have 2 less parts than myself when all is said and done on your end. So I've got the top shell, bottom shell, springy lever, 2 thumb wheels, and 2 plates. Now my parts were quite stiff to start off with, so I'm going to take my knife here and just clean them up a little bit so that everything works nice and smooth. I'll fix up these parts by just taking my knife and shaving a little bit off the areas that are stiff to give them a better tolerance for each other. Once I do that, everything should work the way it's intended to. This step has the potential to be either really quick or take a really long time. My parts came out pretty rough, but if you used a nicer printer, you may not have had a whole lot of work that needs to go into them. With that finished, let's move on to the electronics. So we've got 2 schematics that we downloaded in the last part of the series. One for the power switch, charging, boost, and battery circuits, and another for the Arduino OLEDs, NRF radios, deadman switch, and throttle. Now, I'm not going to try and explain how to solder because there are plenty of tutorials here on YouTube on how to do that from people that actually have a lot of experience and know what they're doing, so I'm simply going to show you how I'm wiring up my controller, because when I first looked at the schematics, I felt a little overwhelmed and I would have really appreciated a video to talk me through how to wire everything up. I'm going to use this bit of cardboard here to protect my work surface from any runaway solder. And now we'll start with the charger and boost circuitry. More specifically, we're going to start with the LiPo charging circuit. As you can see here, I've already prepared an example of what we need the charging circuit to look like. We're removing a small surface mount resistor and replacing it with this new through-hole one in order to limit the charging current for the battery. I removed the original resistor with a knife and a little bit of force. However, this is not the recommended way to remove said component. There is the potential to damage the solder pad on the board. Now, with that surface mount part gone, we need to replace it with the 5 kilo ohm resistor that we got in order to change the charge rate for the board to something more safe for the small battery we have. You can start by first bending a resistor leg around on itself so that they are almost parallel. This will let the resistors sit as close as possible to the board while also not shorting anything out that it shouldn't. Once you're happy with the bend, you can snip off the excess. Now you want to do the exact same thing on the other end. And when you're done, you'll have a small resistor in an oval shape to solder onto your charging board. It took me a little while, but eventually you'll end up with a charging board that's safe for your LiPo battery. Now with that out of the way, let's connect the battery to the charging board. I started by first tinning both the battery leads as well as the pads on the charging board. Before you solder the battery to the board, take note of the markings on both the battery and the charge board. You want to make sure that you're connecting the battery's plus to the bat plus on the charging board, and likewise with the battery's minus and the bat minus on the charge board. It's very important for your safety you make absolutely sure that you have them correct. To make the wiring process easier, we'll be color coordinating everything moving forward. For this side of the circuit, the red wires will be all of our positive terminals and the black wires will be all of our negative terminals, just like the schematic. Now with that out of the way, we'll move on to attaching the USB port. This part was actually quite confusing for me because of how it's wired. There are 5 small pads on the USB port. You need the outermost left and right pads in order to get power from USB. I initially thought that the wires were supposed to be parallel like this, but with the solder pads on the USB port facing up, the wires will actually cross and make an X. It took me all night to figure out why the board wasn't working, so don't make this same mistake that I did. With all of that figured out, let's move on to the next pieces, the 5-volt boost converter and the power switch. I wanted to test my components first to see how they would fit together in the housing, and it took a little finagling, but I made it work. And as you can see here, we'll be connecting the following solder pads. The charging board bat minus to the in minus on the boost circuit with black wire. Then the bat plus will be going to the in plus on the boost circuit with red wire. But in order to turn the remote on and off, we need to add a switch between the bat plus and the in plus. So let's attach the switch to the boost converter first so that we don't forget. Now let's do the black ground wire. Then we can do the longer red wire from the switch to the bat plus. Once you're done, it will look like this. The red in plus will run to the outer pin on the switch. The inner pin on the switch will have a red wire running to the bat plus. The black ground wire will be between the in minus and the bat minus, as you can see here. Now, when you flip the switch, a little blue light should turn on the red boost converter. If everything is working, then you can go ahead and solder on a long red wire to the out plus on the boost converter and a long black wire to the out minus on the boost converter. Then fit the whole shebang into your housing like so. And for safety, you will want to insulate the leads on your switch. I used a bit of painter's tape, but hot glue is a better solution. Now, as much as I'd love to keep going with this video is getting a little bit long. So, you can check back soon for the next part of this build guide, where we'll be tackling the main logic circuitry of the remote. Toodles!